Okay, let's go over notes for chapter 2.4. This is on chain rule. And just to read along here, chain rule is simply a method of computing the derivative of the composition of two or more functions. So basically a function within a function. But let's review some of the rules that we've learned in terms of finding derivative. So if I had a function, f of x is equal to g of x plus h of x, if I have two terms or two functions that are separated by plus or minus, I can treat each like a separate problem. And so far we've learned the power rule. So we can find the power rule for g of x, which becomes g prime. We can find the derivative for h of x, which is h prime. So if we have a plus or minus in between functions, we can treat each like a separate entity. And we don't have to do anything special in terms of how we combine them. Okay. And we talked about how if we have two different functions that are being multiplied together, it's not as easy as just doing g prime times h prime. We have something called product rule that allows us to combine the derivative, find the derivative that involves the product of two functions. And we learned that was the first function's derivative times the second function plus the second function times the first function times the second function's derivative. Right. So we have a way of pairing a function's derivative with this function. And if we have two functions that are being divided by one another, we have quotient rule, which is g prime x h minus g of h prime all over g squared. So basically going to be the product rule, but then we change the sign from plus to minus, and then we also have a denominator squared. And this should be h squared. Okay, denominator squared. Okay, so now this brings us to, what if we had a function within a function, a g of h of x? Okay, so we have a special way of finding the derivative if we have a function within a function. Okay, so the rule is, if we have a function f of g of x, it will be, the derivative will be f prime of g of x times g prime of x. Okay, so basically we're taking the outside function's derivative, and then we multiply that by the inside function's derivative. Okay, so the steps we take the derivative of the outside function while maintaining the inside portion unchanged. Okay, then we multiply it by the derivative of the inside function. So if we look at example 1, part of the challenge is identifying the outside and the inside function. So here we see parentheses to the fifth power, and outside the parentheses we see that exponent, so we're going to treat that like the outside function. So my outside function is parentheses to the fifth power, and my inside function is going to be whatever is inside the parentheses, so 3x squared plus 2. And let's see if we can find the derivative for both portions. The derivative for parentheses to the fifth power, if we treat the parentheses like one big variable, then we can find the derivative using power rule. Bring down the 5, keep the parentheses, subtract 1 from the exponent, so then 5 parentheses to the fourth. And then the derivative of the inside function, the 3x squared plus 2, will simply become 6x. Okay. So the rule that we're going to follow is the outside function's derivative, so the f prime of g of x. So that will simply be 5 parentheses to the fourth, and whatever is inside the parentheses, we just rewrite it and we do not do any changes to it, okay? Because we have not, we are not yet having to deal with the inside function. Okay, we're just dealing with the outside function's derivative. So 5 parentheses to the fourth power, and then we multiply it by the inside function's derivative times 6x, g prime of x. Inside function's derivative is 6x. And then we can clean this up a little bit more. So this becomes 30x times 3x squared plus 2 to the fourth. Okay. Now imagine what would happen if we were to find the derivative of this function without the use of chain rule. Okay. If we didn't have the chain rule, then we would have to use the power rule. And if we use the power rule, that means we will have to first expand these terms out. And you can imagine how cumbersome that would be if we were to write this out 5 times, and we will have to FOIL, we will have to expand each term and get rid of the parentheses and then evaluate. But then once you evaluate, you will start to find factor and go through find GCF. But here we find the derivative and it maintains its form in factor form. So with chain rule, we're able to do a lot more efficiently. That would otherwise take a lot longer if we had to use power rule, for instance. Okay. All right. Example 2: find all values of x for our function for which f prime is equal to 0 and where f prime does not exist. So before we can figure out where f prime is equal to 0 and where f prime does not exist, we need to get to f prime. So first thing we do is we want to rewrite it. So f of x, we can rewrite it as x squared minus 1 to the 2/3. Okay. We can find the derivative, and hopefully you see that there is an outside function and there's an inside function as well. Okay. The outside function will be similar to what we see here, except now it's going to be parentheses to the 2/3. And the inside function will just be what's inside the parentheses, x squared minus 1. Okay, so if we want to find the derivative, we first find the outside function's derivative. So we bring down the 2/3, we keep the parentheses, we subtract 1 from the exponent. So 2/3 minus 1 is negative 1/3. So now this takes care of the outside function's derivative, but now we have the inside function. So x squared minus 1, the derivative for that will be 2x. And the 2x and 2 can combine to be 4x, and we can bring the x squared minus 1 back down to the denominator. So 4x over 3 times x squared minus 1 to the 1/3. Okay. Now to find out where f prime is equal to 0, we're going to set just the numerator of the derivative equal to 0. So 4x is the numerator, set that equal to 0. 4x equals 0, x equals 0, so therefore f prime is equal to 0. The slope is going to be equal to 0 when x is equal to 0. Okay. If we want to find out where f prime does not exist, we just have to set the denominator of the derivative equal to 0. So the denominator is 3x squared minus 1 to the 1/3. We set that equal to 0, divide both sides by 3, cube both sides. We're left with x squared minus 1 equals 0. So we get x equal to plus or minus 1. So at plus or minus 1, our derivative is undefined. Our derivative does not exist. Okay, example 3. We have our function. Find the equation of the tangent line to y is equal to y at x equals negative 3. So we want to find the derivative, but we can avoid the quotient rule if we bring the x plus 2 to the top. And if we do that, then the derivative will be a lot more efficient. So the outside function will simply be 4 parentheses to the negative 2. And that's the derivative for that function will simply be bring down the negative 2, keep the parentheses, and subtract 1 from the exponent. So negative 8 parentheses to the negative 3. But now we still have to remember we want to multiply by the inner function's derivative. So x plus 2's derivative becomes 1. And then we combine that to be negative 8 over x plus 2 to the 3rd power. Okay. So we have our derivative. So if we want to find the tangent line equation, we plug negative 3 into the original function, which gives us our ordered pair. And then if we plug negative 3 into the derivative function, that'll get us our slope. So we have our ordered pair, we have our slope, and then we just plug into point slope, and we have our tangent line. Okay. Let me go over some select homework problems. That may be a little bit more complex and more difficult. So let me go over 27 and 29. So with 27, we see y is equal to x over root x squared plus 1. Now this, we can think of this as using quotient rule, x being the top function and then the denominator being the g of x. So in this case, we're going to use quotient rule, and then there's the chain rule portion. So you see the chain rule portion will affect this parentheses to the 1/2. And the way you tell, especially if you're dealing with multiple rules, the way that you tell which one to use is you want to use the rule that affects the largest piece of the function, or that affects the entire function, basically. So the x and the x squared plus 1 to the 1/2, the rule that is going to affect this entire function will be the quotient rule. So we take care of that first. Now the chain rule will come next. Will occur inside the quotient rule, because when we're ready to find the derivative for that denominator, then we can apply the chain rule. So we're going to go through quotient rule first. F prime g minus f g prime all over g squared. So f prime, x becomes 1, and then the original g function is x squared plus 1 to the 1/2. Okay, minus the original function f, so that's x, times g prime, so times the derivative of the denominator. So this is where we got to go through chain rule. So chain rule, we take care of the parentheses to the 1/2 first. So we bring down the 1/2, keep the parentheses, subtract 1 from the exponent. So that gives us 1/2 x squared plus 1 to the negative 1/2. And then we multiply it by the inside function's derivative. So then x squared becomes 2x. Okay, all over denominator squared. Okay, so now the remaining steps is just to clean all this up. Here we have 2's that cancel out, bring the x squared plus 1 down to the denominator. But we're left with a complex fraction, which we can undo by multiplying numerator and denominator by the term that is causing that complex fraction. So if we distribute the root x squared plus 1, these two terms will give us x squared plus 1. The root will go away. Here, if we distribute this through, the root x squared plus 1 will cancel out, leaving us with just x squared. And now we have x squared plus 1 times root x squared plus 1. Think of this as x squared plus 1 to the first power and x squared plus 1 to the 1/2. If we want to multiply bases, we add exponents. So 1 plus 1/2 gives us 3/2. And then the numerator will cancel out to just be 1, and so we have our derivative. Okay. 29. We also have quotient rule and chain rule, but notice that how this is a little bit different. Here we have the parentheses that is affecting the entire function. So that means the chain rule will come first, because chain rule is going to affect a larger portion than the quotient rule. So the chain rule will be the first rule applied, and then within the chain rule, then we have these terms inside the parentheses. So the inner function will be where the quotient rule is applied. Okay, so we take care of the outer function first in this case. So the outside function is parentheses to the second power. The derivative will be 2 parentheses to the first power. So 2 parentheses to the first power. This takes care of the outside function's derivative. Now the inside function derivative is just what you see inside the parentheses, x plus 5 over x squared plus 2. So we got to apply quotient rule there. So f prime times g minus f times g prime. So x squared plus 2 becomes 2x, all over denominator squared. Right, so now it's just a matter of cleaning up. We can combine terms. The denominator will become x squared plus 2 to the third, and we can just leave it in factor form like this for g prime.